Okay, so now we are up to the worksheet for sequences and recurrence relations. So the first thing we're going to look at are the first 5 terms of the sequence with a starting value of 8 and the rule add 3 to each term. Okay, we looked at recurrence relations before, so we know we can write this sequence in the following format. So we've got v0 equals 8, and we've got v n add 1 equals vn add 3. Now what we know, we can start at 8 and add 3 each time. So we have 8 add 3 is 11, then we have 14, 17, and lucky last 20. Okay, so we're adding 3 each time. That's basically it. So number 2, we're going to write down the first 5 terms of the sequence with a starting value of 2 and the rule triple the number then subtract 2. Okay, a lot happening there. This can be written as the following. v0 equals 2, vn add 1 equals 3, multiplied by the previous term, which is vn, subtract 2. Okay, so this is what we have to do each time. Okay, 3 multiplied by 2, subtract 2, it equals 4, and we have to use that 4 again. 3 4s, we get 12, subtract 2, we get 10. And as you can see, we're using 10 again, okay? Now with the other term, we get 28, and then we use 28 again, and we end up getting 82. Okay, so therefore we get 2, 4, 10, 28, and 82. Okay, now the next bit is that we have to do the same thing, but we're going to be using our class pad. Okay, so what I need to do is actually get the class pad up. Remember, this is your friend, okay? This is something you all have to use, and it will definitely help you, and I'll show you why. Okay, so with this, we are starting at 3, vn subtract 2. Okay, so what we're going to do is go 3 multiplied by 2, which is the initial value, then subtract 2. Okay, as you can see, we get 4. Okay, now what we're going to do is go to keyboard, okay, and we're going to substitute answer or ANS in our next line. So we're going to go 3 multiplied by the answer, subtract 2. What this does is it uses the previous answer. Okay, so when we set it up, it's amazing how fast it can be. So we go execute and we get 10. We do it again, 28, and we should get, and if you haven't guessed it yet, it should be 82. Let's see, 82. And if you're really bored, you can just keep pressing. And as you can see, you just keep going all the way. And if you want to, you can try to break the class pad, but it will just keep going and going and going. Okay, so don't worry about that. Alright, now, the really good thing with mathematics is always multiple ways to get the same solution. So, with recurrence relations, the other way is to use what we call the sequence tools. So, the way we get there is we go to menu down here, and as you can see in the menu section, we've got all of these applications we could use. So we go to a sequence, and now we've got 2 different types. So later on, we're going to be looking at what we call explicit, and we're looking at recursive relations at the moment. Okay, so the difference is with recursive, we get all of these different values that we're seeing here. Okay, with explicit form, we want to get a specific value at a specific time. Okay, that is the difference. So now what I'm going to do is input the recurrence relation. So I'm going to go 3. Now you may have noticed instead of V we're using A. Okay, I need to let you all know that this can change. It doesn't always have to be V. Okay, as long as you're all consistent with what you're doing. So I'm going to input AN, subtract 2, and this one here where the 0 is, we're going to make that 2. That's our initial value. I'm going to tick the box, and I'm going to go graph. Or what I really did is instead of going graph, I actually went to table. And as you can see, I've got the table of values. And I was really lucky that my initial value there was 0. Now, usually that does not happen. So what you have to do, you have to change the step by going to the X, Y, as you can see up here. And you can go start 0 to 4. Okay. What you might have to do later on is change this end value to something a lot greater. Okay. Now, you might see up here that we can actually graph these recurrence relations, and the answer is we can. Now, have a look at that. Okay, this is the shape of the recurrence relation. Okay, now if you are not getting that value, remember, just like with normal graphing, you can change the window. Okay, you can do that manually if you like, or you can go to zoom, quick standard, or you can go to auto or square. It's really up to you what you do there. Okay, so that's another way to work out the sequences. Okay, let's keep going. Okay, we've got 2 more here. So this time we're going to write down the first 5 terms of the sequence defined by the recurrence relation. V0 equals 10. So we're starting with 10, and then we're going Vn add 1 equals Vn add 5. So each term after 10, okay, we're adding 5. So this is the actual proper way we have to write this out. V0 equals 10. Now we substitute 10 into the relation. So we've got 10 add 5. You may notice now that V0 now turns into V1. Okay, that is the next term in the sequence. And as you can see, V1 equals 15. Now, we're going to use our 15 for the next term. So V2 equals 15 add 5, and we know 15 add 5 equals 20, and there we go. Now, what I've done is, I've changed the colour so you can see where I'm inputting all the values. So V2 equals 20, we put it into the next term, so 20 add 5, we get 25. And we do it one more time, so V4 equals 25 add 5. Now we have V4 equals 30. Now if we add up all our terms, we should have 5. So they're the first 5 terms in the sequence. Okay, the next one, 5. A sequence is generated by the recurrence relations V0 equals 400, 400, and Vn add 1 equals 0.4 Vn subtract 8. Use a calculator to generate a sequence and determine how many terms of the sequence are positive. Okay, there are 2 ways to do this on the class pad. I've shown you one of those, which is the main screen. The quickest way, as I was showing you previously, was using the table. We're going to use a table for this one and really smash this out. So what we're going to do is now just change what we've already inputted in. Okay, I'm going to just go edit clear all. Alright, now what I'm going to do is just slightly move it over here so I can see what I'm doing. Okay, I want 0.4. I'm changing that now to an subtract 8, and my initial value is 400. Alright, now it's really asking for an answer here. It doesn't want me to do any graphing, so I'm just going to go to table. Whoa, and look at that. Okay, my initial start is 0. Okay, V0 equals 400, so that's the initial value. Or in our case, A0 equals 400, okay? As you notice, the value of n changes with each time there. Now the question is, how many of these values is positive? Okay, and 400 is positive, we've got 152 is positive, 52.8 is positive, isn't it? Yep, good. And then we've got 13.12 is positive as well. One thing you might notice as well, I'm clicking on that value. The reason being is sometimes what you see in the table is just a rounded value. Okay, so later on, I would like you all to start clicking these values so you can see it properly down there. And then A4, okay, is a negative value. So therefore we've got 4 positive values. Okay, so let's have a look here. Yep, that's our sequence there, our positive values, and then we've got 4 terms that are positive. Okay, so there, Once again, thank you very much for watching this presentation, and please let me know if you've got any questions or queries. Okay, see ya. Bye.